To continue on with our calculations using the mole, we're going to learn about molar mass. Essentially, this is the mass of 1 mole of a substance, no matter what that substance is. Remember how we had carbon on the periodic table, and we found out that one atom has a mass of 12 AMU. And then we saw that essentially 1 mole of carbon has a mass of 12 grams. Notice that an atom that weighs 12 AMU, a mole has a mass of 12 grams. So it gives us a correlation. Whatever the atomic mass is of that element on the periodic table is the same as the mass of 1 mole of that substance in grams. Let's do a few examples. Calcium on the periodic table has an atomic mass of 40, which means that 1 atom of calcium has a mass of 40 AMU. But doesn't that also mean that 1 mole of calcium weighs 40 grams? So we're going to make a conversion factor out of this and say 40 grams equals 1 mole, or 40 grams per mole is the molar mass of calcium. With sodium chloride being a compound, we have to add up all its atomic masses. We have 1 sodium weighing 23 AMU and 1 chlorine weighing 35 AMU. Well, that means if we add those together, 1 formula unit of sodium chloride would weigh 58 AMU, and 1 mole of it would weigh 58 grams. So the molar mass of sodium chloride is 58 grams per mole. Let's use these molar masses in some calculations. Imagine we had 11.2 grams of sodium chloride, and we wanted to find out how many moles of sodium chloride this represented. I'm going to put the 11.2 grams of sodium chloride, and with only having 1 unit, I put it over 1. The molar mass of sodium chloride, if you remember, was 58 grams per mole. So what I'm going to do is I'm going to write it out as 58 grams per mole, but put the 58 grams on bottom so it will cancel out. Essentially, I'm going to take the mass of the sodium chloride and divide it by the molar mass, which is going to represent 0.193 moles of sodium chloride. Imagine we were going to go the other way. If I had 1.35 moles of calcium chloride, what mass does this represent? So imagine I put the 1.35 moles over 1, it only has 1 unit, and now I need to use the molar mass of calcium chloride to figure out what is the mass of 1.35 moles. So I look up calcium on the periodic table, and it weighs 40, and chlorine on the periodic table weighs 35. 40 plus 35 plus 35 represents 110 grams. Notice the molar mass is 110 grams per mole. 1 mole of calcium chloride weighs 110 grams. I put the moles on opposite sides of the fraction, and I'm going to take 1.35 times 110, and I'm going to get 149 grams of calcium chloride. So if 1 mole of calcium chloride weighs 110 grams, then 1.35 moles should weigh a little more, and it does at 149 grams. So let's go all the way from mass into particles. We're going to have to use 2 different equations for this, and we're going to do it in dimensional analysis in 2 steps. I'm going to write down 1.5 times 10 to the 23rd formula units, and I put it over 1 because it only has 1 unit. So I need to get this into mass. Well, you can't go straight from formula units into mass. You have to go from formula units into moles and then into mass. A famous saying I always come up with is, once you have moles, you can go anywhere, my friends. Anywhere. What I'm going to do first is I'm going to get these into moles. A formula unit is a particle. So I'm going to use the equation on the left side. So I say there are 6.02 times 10 to the 23rd formula units per mole. Now you'll notice the formula units have canceled out and we're left with moles. If I was to stop the calculation there, we would have it in moles. But we want to know the mass. So what we do is we look up calcium chloride on the periodic table and we get its molar mass. And if I remember correctly, the molar mass was 110 grams per mole. Notice we canceled out the moles again. If you look at all the units that are canceled out, they're all canceled out except for grams. So we take 1.5 times 10 to the 23rd, divide by Avogadro's number, and then multiply by the molar mass, and you get 27 grams of calcium chloride.